All right, we can continue from here. So I had to, I actually mix it up a couple of versions, so not released versions, etc. Had to stop. So I turned back one of our base versions. That's why it took a little bit long. So, okay, we can continue our webinar. So what I was saying before, it's actually CAD and GIS solution, which is quite unique. You can't find a lot of software does this. And what I mean by that is a layer manager here, and you can add a couple of layers. It just works like other CAD software. At the same time, you can also work with raster images or satellite images. You can bring them into the table. So for data preparation and the other stuff, it's really helpful. Um, I would like to talk about also a little bit interface, like we have all of the drawing tools in the home page, editing tools, etc. But what makes it also a little bit different, we do also have packages. So until until this part, this is the calculation tool. Until here, it's just belongs to NETCAD GIS, and also you can bring another packages like NetSurf. It's another module or another package. As at the beginning, Mr. Yan has mentioned, we also have other modules, like when you install them, it's actually coming here, like roads, excavation tool, etc. So as a tab, you're also having lots of different features by installing them. All right. So we talk about raster data and the vector data. Now, I would like to show something about it. So we make this part clear. We do have different data types, and when we work with the CAD data and the raster data, this is the separation between them. So one of them is actually a raster data, and the other one is the vector data. It's not about clarity all the time, because in the raster data, there's a pixels, and you can get small pixels and you can get a good quality. But no matter what, in any raster data, when you zoom in, you're going to see the pixelation because it's an image, and those pixelations have color codes. And according to the color codes, when we zoom out, we actually see the clear picture. But when we zoom in, we can see the pixels, and it's not a good quality. On the vector data, however, it's never changes because it represented with point, line, and area information. So we are also going to see that in the further processes of NETCAD GIS and our applications. And there's also a real data. Real data is more complex. And we are trying to bring a raster image and just an image, a flat image. We are trying to adapt that image into our world's shape. Therefore, we need to make some projection definitions. So the world is like that, and we are trying to put that image into, we are getting some image from the map, but we are drawing in a 2D environment. So we are trying to adjust that image into world's conventional surface. Okay, that's why we are also making a projection definition. So before we start, I just wanted to mention that also. Now let's start with adding some file into our software. Maybe we can start with adding a raster image. Sample data for GIS. Okay. All right. Now, I do have a raster image now, as you can see. And in that raster image, now I'm going to show you the pixelization also. When we zoom in, yeah, we can see the pixelization. It's a big, good image. It's a nice map, but even though when we zoom in, there are some pixels and quality is different. That's why when we turn that information into a CAD information, it actually becomes more clear and the vector data doesn't change. In some cases, you might also see some icons like those icons when you change the resolution of your computer changes, but the vector icons, vector drawings, it's not changing. And the first thing that we would like to do, we have a map of the area, could be a mining site or any other project that we would like to work. We have hard copy map. And that map carries some information, geological coordinates, like minutes, seconds, and also a metric coordinate like this one, X and Y coordinates. But my software, it's also a space. It's a really huge space that I do have my own coordinates also. And it's working exactly like the coordinate system, um, as long as you go left, right, or whatever, it changes. So it has its own coordinate system too. What we would like to do, we would like to adjust our raster image into coordinates so that we can work much more closer to the real environment. So how it's going to happen, let me say, when we adjust that image and when we make a digitization with some small error percentage, we are going to get, let's say, area information of this yellow area. It is going to be close to real one because we are going to make the coordinates transformation. Okay, we are going to make that projection definition. And also, I do have 4,219,000 coordinate in here and 544,000 coordinate in here. So that point actually should be this coordinate, this exact coordinate. Therefore, we are going to make a raster preparation and the transformation. So to start off with, we can double click on the world icon and it's a passive right now, but we need to define our projection. So which projection we are going to use? We need to select the UTM information and the datum information. That depends on the location that you're working with. So I think in Indonesia, there's another datum that you can use. And the UTM is depends on the size of your map. Like if it's a big map, you can use the 3 UTM. If it's a small scale map, you can use 6 UTM. And this is this is the UTM and datum definition for my map. And I can also select the city that I'm going to work on. But in the world map, I can also make a selection. So the city that we have here, this one, it just takes the longitude information. So in here in the central meridian, actually, I changed the longitude information according to the UTM-6 now. And if you see that there's a EPSG code. So now every place on Earth have EPSG code. You can check that information even on the internet. And according to the zone, according to the region that you're working in, you can just directly type the EPSG code and that projection and datum definitions will be automatically adjusted. So let's copy that EPSG code. Let's say I change 3, this. Okay, it's generating another EPSG code. But when I paste that EPSG code, it just turned back to my settings right now. I click OK. Click OK again. So we made the projection definition. And in the raster preparation, there is also an option because map sheets also know every piece. Let me check. I think we had that information somewhere here. Yeah. Those map sheets are actually those squares. Like it can be J19, J20, it goes like that. But every place on Earth have a map sheet, and then we divide it. Like in that example, L19, and we divide it into 4, and the fourth piece becomes D. And if you divide that information into a four piece again, the fourth one in the corner, it's this map. So it's actually coming from one of those map sheets, but when we divide it, it becomes D. When we divide it again, D4. When we divide it again, D4, something else. Okay, D4, A, B. It goes like that. So therefore, we can type the map sheet name, and when we apply, it's going to bring its map sheet. Okay, now you can see we become closer to the project coordinates even. But the space, the 2D space that told me that this map actually in this region in that map sheet, because it's the original sizes of the map sheet according to the coordinate. It is actually bigger than it looks. So my map actually should fit into that space. In here, we have a couple of options, like we can produce a point from known coordinates. For example, I know this coordinate, right? Let me check. So this coordinate, I can create some points and carry raster image coordinate into that point. But we don't actually need that because this is a full map that actually sits in that map sheet. So all I have to do is the corner locations. Actually, corner locations of the map should fit into this map sheet. Okay, let's do that. Let's transform our raster image. So now we are going to add points. Actually, adding points operation is just adjusting the corner points for me now. Let's get a little bit closer to, okay, I see the pixelation. I got that point. Okay, we adjust the first side. For the second one, I do get this corner. Okay. It's a little bit big map, so I need to get this part. There here. Okay, the last corner. Okay, I catch that location too. And when I right click, it will bring the points here. So it just checks in the image coordinates, the location that I selected is this. You can think like when I import the image, it was the image coordinates, but now the image's corner coordinate should be in this coordinate, in the real coordinate. So it also calculates the average error, which means we can make slight mistakes while we're transforming that kind of a huge maps. This is a 1 divided 25,000 scale map. So in 25,000 scale map, you can the acceptable error rate actually 1 in 5 as a millimeter. We multiply that number with 0.2, which is 25,000. 1 in 5 is just 5,000 millimeter, and 1 meter is acceptable range for the error rate. But of course, if you make less error, it will be better. In here is 1.13, so 1 meter, 13 centimeters like that. Let's transform that. It also asks me how we would like to save. We are saving as a TIFF image, and when we save that as a TIFF image, it's actually carrying the coordinate information in the image. Now it becomes a TIFF and it has a coordinate information now. Now let's check if the transformation operation is successful. So when I bring my mouse cursor around here, so it is almost like the exact coordinates, right? For the X side, 4,219,000, and for the Y side, you can check the coordinates that comes from the software. Yeah, around here, I have the exact coordinates with few small error rate, of course. Now, I do have a map that sits in the exact location that it should be. Now, I can make some editings, like I can add visibility area. I can select the map sheet, and with that, I can isolate only the map that I'm going to work on. Or I can draw another area, let's say this region, and I can isolate this region that I'm going to work. Let's do that from the properties. First, I remove the visibility area, and then I'm adding an area to work on. So this time I'm not going to select the map sheets that I have. I will draw an area like this area, for example. Now the as isolated. Okay, that's better. And also we can bring online maps into the table. Now, only the satellite image we can see, but we can carry that raster to the top. Now we can see the raster image. We can give some transparency to the raster image, and we can see how much it fits actually with the information that we have on the satellite image. Because we have that projection definition, we also have the satellite image according to that projection definition. So we don't need to adjust the satellite image once again. So this is a lithological map of the region. But if we want, we can also get the satellite image as well, if we save that as a geotip. Let's, okay, satellite image can stay, that one. I will save that image as a geotip. Output location, satellites. And we are going to add that satellite image in a TIFF format and into our references. Yeah, it will take a minute or minute and a half. Okay, maybe more more than I thought, because estimations can be wrong. But we are transforming, or actually we are getting 1 to 25,000 scale satellite image with the good quality. So if we don't have any raster image, at least we can get the satellite image to work on in that region, in that zone. Okay. Didn't complete the process. I think it got some sort of memory issue too. Quality is not going to be good if I save that as a 3 pixel, but all right. Anyways, it got some sort of an issue here. But we have the satellite image anyways. I can get an image as a PNG and I can make adjustments like this raster because that was a PNG file. I can get an image and make an adjustments, but that wasn't what I want. Anyways, let's continue creating our terrain model first. For the terrain model, I'm going to upload a vector file, which is going to be surface points. Data starts from second row of the exact. Actually, that would be better if I show you the sample data. So okay, so I do have the PNG of the satellite. I think this is the same region. And I have this is the same satellite image too. Okay, maybe I can upload it. So in the surface points that we are importing at the moment, data starts from second row. Actually, the first row is just the titles like X, Y, Z coordinates of the surface points. That information can be different things also like DWG file. If you have a DWG file or DXF file of a surface, you can directly import it. If you have a point cloud like this, you can import it. Right now, I'm importing that surface points. Point name was located in the first column. Second column was Y, X, and Z. Now, I don't have any other information in the Excel, but I have that is going to be important. That is going to be imported as a point code, GIS class code, which is not. So if there's an extra information in the fifth, sixth, or seventh columns, you can just type 0, and you're not going to import any information besides from the coordinates and the point name or number. When we do that, it is the wrong one actually. In the GIS, it should be this. Okay, surface points of the belonging map. All right. Does the same information, does the same operation. And also let's add, okay, now I have points, I have the satellite tip, and I have the raster image. But I think that satellite tip is also has to be adjusted. So check this one. Okay, this one also has to be adjusted. All right. So I'm deleting this layer and opening the points. Now, we do have displaying options. Now I'm seeing the point names actually. That's why it's so crowded. So in the display function, if you uncheck the point names, we are not going to see the point names, but we can see the elevation of the points if you want to as a point Z. If we check that information, we'll be able to see that. And it's colorized according to the elevation. There's a fast isolines option. If you uncheck that, we are again going to see the elevation of those points, but without different colors. Okay, what we need is just the points. So now I mentioned about CAD and GIS differences in that part. We bring CAD objects, which is the point object. Okay, so the point object is actually a vector object or a line or area. Let's create another layer for sample usage. It's a tree, and let's draw a line kind of object. What I would like to show you is in the line objects, no matter how much you zoom in, you won't see any pixelization. That's why this is a vector object, and also the points. You can zoom in as much as you want, but it's just a point, and it's a vector type of image. And the difference between vector and the raster was just an image, and we couldn't get any information. Now, once we have the vector image, it is a different story because the vector image, the point actually holds XYZ information. And if we draw, let's say, area, okay. Now I'm using a polyline. Maybe it's not going to be the exact. I'm drawing an area for that piece here. On the map, it's a lithological, it's an area actually belongs to the different lithology. Okay. Now, if I want, I can hatch this area with the color of my layer. Let's do that. Now, I actually digitized that area. I know it's not perfect. I could zoom in and maybe draw a little bit more, in detail, but it will work. So if I query the object properties of this area, like that, and I'm going to be able to see the area information. Now it has area information, and also it has coordinate information of the polyline and each point that I draw. So it's actually, in another way of saying, it's an intelligent data that what we have here. And according to our needs, let's say this is a lithological piece and we would like to separate it from the other lithologies and we would like to specialize, then we can go to its layer settings and go to the area. We can do some hatching. We can adjust that area according to our needs. We can browse lithology in the library. Let's say geology. Let's say it's a mudstone or sand. Let's find something distinctive, like, okay, let's say this one. In here, I bring that hatch into this area, but I can also adjust the size. Now, this is how it looks on the area. Now I adjust the size of the hatch. And from now on, this is a different area with different hatch. And I can name it as what was our silty limestone. Okay, let's say limestone for that. Let's change the name, limestone. Let's draw another area for here. And this time for the lithologies, to be able to manage, I'm going to create a lithology layer with @sign. And this is going to be a group now. Okay, this is the lithology group. I'm not going to do any operation with that, but it's will help me to manage those lithologies. If I add another lithology layer as a lithology underlined, let's say sand, okay? Now it will go under this lithology layer. Also a limestone. I can carry inside the lithology and it will become lithology limestone. When I select and it becomes bold, that means this is the active layer that I'm using. Also, we can see the active layer in here. Now, let's draw that small piece over there for sand lithology. Okay, it can be hatched, no problem with that. The color of this region could be quite similar to what we have here, but also we can assign another hatch to this area. Well, it looks actually okay. Let's do that. Okay, now it's hatched and I know it's a sand lithology. So it's a lithological map, and look how you're digitizing it. So the sand patch and the sand areas. If I want, I can manage. I can make invisible the sand layers. I can see only the limestone area, or the opposite. Or the lithology layer itself allows me to manage all of the lithological drawings. With that, we are capable of managing the data. We can get area information. We can differentiate different lithologies. We can assign hatches, and all of those digitization operations can be done. In the meantime, we also added the surface points. Why we add the surface points? Because we would like to generate a terrain model at the same time. We would like to see the terrain model. For that, we are going into a NetSurf package, NetSurf module, and we are creating a triangle. I need to select the objects. There are lots of different ways of it. I can select all because it's the only information available on the screen, or I can use the window and make a selection of points. I right click. Okay, because of mm, okay, anyways, so we can analyze all of the triangles that going to be produced. Like it says, the shortest triangle edge, the shortest triangle length that we have when we triangulate those points is 125 meter. The longest edge, maybe from here to here, something like that, is 6,501, and the average is 200 meter, around that. If we use automatic, it'll actually solve our problems because we don't have any broken lines, we don't have any holes or outer boundaries here. So automatically from those points, we can create a surface. So when we preview, if we can't say the boundary, it is not going to create an area in a shape that we want. We need to see the outer boundary. So this is the outer boundary. This is the area that we are going to turn that into a triangle model now. We can increase that criteria or decrease that criteria in some sort of a shape. It is really helpful because you do have a curved shapes, and when you adjust that criteria, it just takes the curved shape. Otherwise, it would create a triangulation everywhere. So when we click OK, it actually creates the triangle. And that triangle doesn't have contour lines. It's just comes from the display settings because we do have the fast ISO line. So according to elevation, it also thematizes. But if you uncheck that setting, you will only see the triangulations everywhere. It's not a contour line. Let's not mix it with the contour line. It's just ISO line that gives you colored shape. Now, we do have the terrain model now because we do have the triangle surface and we do have the raster image, even though it's under the surface now. We do have both of the information. And from the tools, 3D, we can send that information into a 3D so we can make a display. All right. And this is another tool that we are using. This is a 3D tool. Um, if you join another webinars for NetPromine, maybe you kind of might be familiar with those things like the navigation tools, sectioning tool. It is quite similar with our mining solution too. And that format um, can be used, can be transferred to our mining solution too. In that way, they're communicating. So we have ready to use terrain model, which we have the map on it. We draped it. We adjust the coordinates for this map, and it's ready to be worked on. So different lithologies, I can see it on the map. How we can use that information, it's kind of like a lithological map, and when we digitize it, actually, we can manage different lithological areas. And you can also check if it intersects with your mining area or not, or how it's affecting in which lithology you have in your mining area. Maybe in the right corner, it's that the green one, different lithology, and in the left hand side you have a different lithology. According to that, you can also make some practices. Okay, that kind of operations can be done in NetCAD GIS. And let's make another operation. Yeah, maybe I should save that project as a webinar 223. Okay, maybe we wanted to turn back later on. Now, closing it, let's do something a little bit different. It is going to be quite the same, but this time I'm going to add a file, different files. Now I do have different points. This is the surface point. This is the slope top, and this is the slope bottom. So I have different measurements, and I do have a slope like this. This is the top side of the slope, and this is the bottom side of the slope. And also I do have the surface information. How do we manage that kind of information, or let's say a complicated information? It's a CAD management, right? So for the point one, I'm checking what kind of information that carries. So the top side of the slope that I have. So I'm going to say slope top points for them, and I'm going to give it another color. So therefore, it's going to be slope bottom, and it is going to be a green one. And the surface points, okay. And the surface points, it's just surface points. It can stay blue, but I will close them for a while. Now, what I would like to do, I would like to create some hatchings for those slopes in a 2D mapping that might be useful, or maybe later on you would like to create a 2D map report from your open pit, and if you are going to provide a hard copy map, then you can make that kind of slope hatches in also in your open pit mine. If you import the bench and berm areas. You can also make that operation too. I do have the points now. It is quite the same actually. Either you have the points or polyline itself. But since I do have the points, I am going to use a manual head slope. And I had to catch a point while I'm doing that. And I will select one by one manually. Actually, I would have selected manually one by one, but we do have uh, a good features in terms of that operation. So we do have a point name feature. So SU41 point is my last point. I'm going to use the point name feature from here, and SU1 to double dot, SU, I think it was 41, and I will click OK. And every 1 point, one by one, it will draw the area. I mean the line, sorry. So 41, I'm not going to select anything else. Right click, and now it asks me for the bottom. Okay, it started from actually, didn't I catch the SU1? Okay, now it's the red one, and okay, let's do it again. Actually, we have the drawing. Maybe zoom in, zoom out, trouble. Okay. Without selecting a point, I deleted that line. Let's turn back to the operation. The head slope from SU1 to SU41. Okay. Now, for the toe, right click for the toe, selecting the first one, point SA1 to 40, 46, and the operation. And I'm going to do a normal hatching. Okay, directly, so besides from slope, I will make other layers unvisible. So this is the slope hatch that I have. Let's do the other one too. So it's 4203. Okay, 61 different. Hundred and three. Okay. Right click and 4709. That one is extra. From the beginning, so now I'm not going to delete the group. It already does, but for that, it also catches from the starting and ending location also. Anyways, we get rid of that one line. So we have surface points now and all the other points. But the difference is this time we do have slope hatches. And when we have the slope hatches, it is actually a different operation while we're making a triangle in NetCAD. I think I do have the raster image of that too. sample surf, this one. Yeah. So without slopes, I make unvisible all. As you can see, that slope patches just fits my raster as well. And I do have a ready to use raster image because the projection is defined. It's a tip file. But the tip file can match directly into the location that I've been working on and other things. Let's make visible other stuff too and create our triangle. Now, I would like to use all of the objects. First, it's going to use the points. And this time I will say broken lines. And then it will ask me select the broken lines. So broken lines is not going to be points while I'm selecting. Could be arc, symbol, line, and all the other information. So this time we are not going to select points. So I can select the broken lines that I have here. Let's preview. I think 550 also fits for that map. For a broken line, there are a couple of different methods. I think the normal one will just work. Yeah. Let's send that surface triangle and the raster image together into a 3D. So we are going to have a 3D figure with the slope patches. It's actually uh, directly does that levels in a, I don't know, is it, I think it's a 45 degree, like without creating any, because if you do that operation without hatches, it's not going to look 45 degree directly and decent like that. It will just catch the points and it will create a different triangulation. It's not going to work. But with that type of a hatchings, we will be able to show the slopes well. Although we can get a section that I'm not sure how well it is going to look because it's just it's also just a line. So let's check from here to here. Let's get a section. Okay, not bad. So this is the section that we have, and we can see the slopes well. All right. So let's say we worked on our project like this, and what other things we can bring that into the table for in terms of at least reporting that project. We have lots of different things that we can talk about in NETCAD GIS, like we can bring symbols. And the symbol files, I think I do have some north arrow symbol file. Yeah, like the north arrow. For my projects. Later on, I can move it if I didn't like the location. Like this. I can bring a scale bar. It's also adjusting itself according to the project. And I can make some section drawings too in NetSurf if I wanted to. But I need an axis for that. So I'll create one layer called axis. I will draw a line, let's say, similar to this. Left to right side, let's say 20 meter. Let's check. Okay. 5 meters for intervals may be a lot. Okay, just a second. I need to adjust because of the zoom thing. I wasn't capable of touching the okay, now it's better for me. Yeah. So 10 meters, let's preview. Every 10 meter. And click OK. Right now, I can see the cross sections that I can bring. Most likely, we don't have too much difference in that project according to this sections. Only one section almost catching the slope, but that's fine. We can put somewhere here. Also, we can adjust actually the size, the scale of these sections, and we can move them. Let's move. Okay, this is my section line. Those are the sections. This is micro sections. And with that, actually, we can prepare an output. Of course, while we're making those drawings, like I did in the draw cross-section part, I can adjust the cross-section sizes. And in detail, it says in which meter of a section that we are. It's 0.130, so we are in that meter. If it was 1, then 1 kilometer in this meter. Also the elevation of the section. So it seems like we are catching only two slopes, which seems correct. I think two times we are cross-passing with the sections. But if it was on the surface, of course, those sections were going to look different. So after that, if we have some other things to add, like in the details, maybe a grid can be added. We can draw box for the projects like that. And we can bring a grid also. Let's say 25 meters, how it's going to look. Yeah, it looks actually fine. For every 25 meter, we bring grid points. Maybe we should move also this once again. You can draw a reference line. You can move that all the objects actually into a reference line while you are adjusting your project, and we can get some printouts. In the printing part, okay, we do have the scale. Let's say 1 to 10,000 scale, and according to horizontal, I'm going to use according to the paper and the scale. It actually allows you to adjust. Let's use preview option and print. Okay, according to this scale and that paper, it's just a little bit big, maybe 5,000. Yeah. So it's going to be 7,500. I think it will fit directly. Okay, and then when we do that, we can get our paper, but before that, maybe we can also add some, let's turn back to layers, some information if you want to add, like project name, 100 size. Is it too much? No, it's actually fine. Big project name, 50 size, like responsible engineer, the date, maybe that kind of information, or not the text, actually, the rich text.
Sorry, Doctor. I think this already on 12.
Exceeding our time. Okay,
Yeah,
I was just closing in.
Yeah.
So
maybe you can close this one, and then we can go forward with the question and answer a little bit, and then we can close the.
okay, let's add this also, and okay. If you have some sort of an information for the project, or also you can use the rich text editor to add that information. Okay, and then okay, now information is a little bit more, but yeah, you actually got the idea. So with the preview, we can actually see what kind of information, what kind of project we've been working, and you can get a printout and you can select the paper size. So if you print out for a bigger paper size in selected scale, it will be much more easy to see it. I'm not going to print it, but we can save that as a PDF and etc. So for the questions, I stop sharing for now.
Yeah, actually, it's only one question from Mr. Adi asking about whether the software can we use the software to open drone photo and visualize scrap. Yeah, so it's basically talking about the importing the data from drone and also the visual grab.
Okay, if it's a LiDAR image like LAS, LAZ files, it can read. Let me find. Let me find the video. Okay, so I'm sharing my screen. So if you have a LiDAR file, we can add that. It is actually a point cloud, LAZ. It can read with its real colors.
Ya, jadi bisa ya Pak Adi ya, kalau emang datanya dari LiDAR atau format kelas gitu ya.
And also it's quite useful if you have, let's say, if it's a so professional LiDAR data, it might have a billion points even. You can produce, here, for example, there's a 13 million points and we can actually produce a new points. We can simplify those images to, let's say, 5,000. We are generating another points over the LiDAR data. So we can also turn that into another point data too. You can visualize it. We can create surface, triangle surface like we did today. There's a dynamic screen, and in the dynamic screen, you can check the changes. Now we have two different LiDAR data from another times. Like we have frame number 1 and frame number 2 in a different time periods. So in that type of occasions, we can draw an area and calculate the volume difference between them. But I think in the video first, we are also going to draw some road path with its elevations, you see. And turning back to area, we are calculating a volume in between the first LAZ file and the second one. So it shows the filling and the cutting volume difference in between those LiDARs. And this is the volume. Yeah. I hope that answers the question.
Ya, omong-omong yang ditampilkan itu memang versi yang berbahasa Turki, tapi jangan khawatir, itu ada juga yang untuk versi bahasa Inggrisnya. Jadinya bisa lebih dipahami mungkin. So I'm just saying that what you show is like showing the Turkish language, right? But we do have like an English version about it. So no
Yeah,
issue with
I
that.
was actually using English, but the video that I prepared, I think it's a Turkish one. Yeah.
Yeah, yeah.
But it's okay. I was using
Hmm,
the software in English, so
ya. Gimana? Ada pertanyaan lagi kah dari sahabat-sahabat semua, rekan-rekan sekalian? Bila tidak ada pertanyaan lagi, mungkin bisa di-sharing
Boleh, Pak
absensi.
Yanes.
Oh ya, silakan, silakan.
Hello to work. I appreciate the presentation.
yeah.
I
Hi.
want to continue the previous questions. If we have a real picture of big areas with various land uses, how can we digitize and give information for varied land uses, such as there is an area for agriculture, another area for mining, and so on? Thank you for your response.
Yeah. Okay. It's actually going to be quite the same, like we did today, in another project file, if I'm not mistaken. So we do have a map, not new, sorry, open. The webinar projects. NETCAD GIS, I guess, webinar. So if we have a raster image like we have in here, let's say the green land is our forest area. So I'm just going to create a forest. It's another thing, forest. And maybe it's going to be roughly area drawing, but to give you an idea how we can make it. So let's draw the polyline. Let's say it's my forest area on the map, right? Point automatically. Yeah, catch the last point. Okay, so this is my forest area. I don't need hatched. I can only have the area also. You remember I got surface points too. So this is my forest area. If I want, I can make a hatch too. I can bring a hatch also, but I can do other operations as well, like digitizing this area and digitizing other areas with the polyline. That is actually how I can do that thing, like lake, for example, with the blue. I need to digitize the different part of, let's take that as a lake that I have. Now, there are lots of good features actually, but in small amount of time, I can't go too much into a detail, but in here, I would like to show that. So we do have surface points in here, right? Like this one, the surface points we bring for all of the map. And I can take that points, I can filter the points basically. Edit, change layers. Now I'm going to change the layer of points inside this area. Now, when I close that and the raster image, yeah. So, oh, actually, I changed their layer into a lake. Sorry, I should have selected the forest. Never mind, I can select all of the objects and change their layer into forest once again. Okay, these are these objects inside the forest layer, all of them. And besides from the area, for the points, I can make some adjustments also. For the points, I can add a symbol to like do I have something look like a bush, or yeah, maybe this 5. Let's see if it's going to be visible. Yeah, it's a forest, and I add some small icons like a tree icons. It's the forest region. Let's make it 10. So this is my forest region. This is the lake. I can do some adjustments to the lake also, or maybe because it's lake, I can just make it solid, so it's going to look like blue. So from the raster image, I can draw the areas and separate those areas. With the layer management, basically, we can add lots of layers besides from the lithological layers. Now I do have a forest and lake. Maybe its geographical status and the usage can be different. I can add usage general layer also, and forest and lake I can take into a usage purpose. What are the usage purposes of this region? Those are the forest areas, the lake zone. I don't know, you name it. We can do lots of different digitization on the map. And we can use all of them, like lithological information. All right, so this is a different lithology inside the forest. We can use all of the CAD layers together. We are actually managing it with visibility operations. Is it answer your question, or you mean something else? I don't know. If that's helpful,
Yeah,
let me know.
yeah. I get it, Tugbuk. I'm sorry, I missed that part because of some activities earlier. Thank you so much.
Okay, all right.
Ada pertanyaan lagi mungkin dari bapak-bapak sekalian? Jangan lupa untuk mengisi daftar absensi yang ada di kolom chat ya. Okay, another question to how to use the georeferencing. So from Mr. Iman.
Is there a more specific part in the georeferencing?
Ada lebih spesifik mungkin Pak Irwan bisa dijelaskan langsung, mungkin di unmute aja langsung bicara dengan itu. Silakan Pak.
Because if it's a raster transformation and adjusting the rasters into our right locations, actually we kind of did that. It was a random raster image. Let me add the original one, the PNG one. I think, yeah, this one up in PNG inside GIS. Yeah, so without DRE information, that raster was just a PNG, like something like even paint output. It was a PNG file, and we import that information into our projects. Okay, now I do have a raster image, but that raster image doesn't have the right coordinate information. We made that raster image so that it can be located in the right coordinates with the raster transformation, and it become raster affinitive And when we find the limit, it is actually inside the original locations. In the properties, I made the legend and other information disappear, but we do actually have the coordinate information. So right now that PNG, it stands in the right coordinates. From here, we can check. So that point exactly, it's in the right coordinates now. We are using transformation for that with the UTM and other stuff. Let's do that once more. So I do have that raster, right? We are using raster preparation, and according to the map sheets, we are actually bringing that raster image into right locations. But of course, after that, it's not going to work. Let's do it in a new one. I'm going to add that raster PNG file again. Okay. Oh, it's actually in right coordinates because we created a DRE information. Just from the start, if we would like to do it, we need to delete the DRE information also, because it's attaching the raster and changing its coordinates. Now we are in the totally random coordinates, and first we do the projection definitions according to the UTM and datum definitions, but we don't always need that because there's an EPSG code in all over the world according to the region that your project is located. You can use the specific EPSG code. Mine is this. When I select UTM and datum accordingly, and it creates the EPSG code. Let's select another things. It creates another EPSG code, but I can use that EPSG code directly, and you can find EPSG code for Indonesia on the internet. There's some websites giving that information. So once we adjust the projection definition, we are making a raster preparation with the map sheet name. Also, map sheet name is known for all of the rasters. Now we do have the raster image in a close location because of the projection definition and the raster preparation operations. Now I got that raster image into closer to the original map sheets, but software tells me that this map, if it's representing that map sheet directly, it should sit inside that boundary, because this is the map sheet comes from numeric data. So the coordinates are known and it's alleged, but the raster image, however, we are trying to fit the raster image into a world shape. So when we have a raster image in 2D like that, it is not going to work directly. Therefore, we need to adjust that raster image, right? So the raster image should also look like this, kinda, at least. So therefore, we need to adjust the raster image. And we are doing that operation by making a transformation. And from the known points of the raster, we are carrying that points into a numerical locations. In that example, I know the corners actually should fit raster's corner points, and the map sheet's corner points should fit. So I'm adding a point and selecting, maybe I'm going to do it roughly this time a little bit. Okay, this corner. In that corner, I am matching. This corner with here. And this corner with that. Once we got that, it's actually, we have the really high average error. It's not quite acceptable, but I will transform it. I will say low accuracy. Yeah. It takes our raster image into that frame. So now it's more or less, again, the same coordinates. This is how we doing the operations.